Hello students, in this video we will study the problems on the centrifugal pump. So let's start with our first problem. The internal and external diameters of the impeller of a centrifugal pump are 200 mm and 400 mm respectively. The pump is running at 1200 rpm. The vane angles of the impeller at inlet and outlet are 20 degree and 30 degree respectively. The water enters the impeller radially and velocity of flow is constant. Determine the work done by the impeller per unit weight of the water. So this is the problem. So firstly we will write whatever given into this problem in a simplified form. So in the first line, the internal and external diameters of the impellers are given, which are represented by D1 and D2, and these are its value 200 mm and 400 mm respectively. We will convert them into SI unit, means in the form of meter. So 200 mm is equal to 0.2 meter and 400 mm is equal to 0.4 meter. The speed of the pump is also given. So pump is running at 1200 rpm, means the impeller is running at 1200 rpm. So capital N is 1200 rpm. The vane angles of the impeller at inlet and outlet are 20 degree and 30 degree. So these are the vane angles at inlet and outlet respectively. So what is vane angle? Vane angle is the angle made by the relative velocity with the direction of the vane. So at inlet, this is represented as theta. It is equal to 20 degree, and at the outlet it is represented by phi, which is given by 30 degree. Now the next line is the water enters the impeller radially. What does this mean? This means that the angle alpha is 90 degree. What is this angle alpha? This angle alpha is the direction of the jet or direction of the flow of the water with the direction of the vane velocity. So if it is 90 degree, in the centrifugal pump case it is mostly 90 degree unless and otherwise stated in the example. In this example it is given as 90 degree as the flow is radial, and this makes the x component of this radial velocity Vw1 as 0. So as Vw1 becomes 0, the value of V1 becomes is equal to Vf1. Means in this case the velocity of the water flow will become as its flow component Vf1. Now the tangential velocity of the impeller at inlet and outlet we can find by using these formulas. U1 is equal to pi d1n by 60 and U2 is equal to pi d2 by 60, pi d2n by 60. So what is U1? U1, it is the tangential velocity at the inlet. So if we replace all these values pi d1n by their actual values, we will get the tangential velocity at the inlet. Similarly, we can get U2, which is equal to 25.13 meter per second. Now this velocity triangle will look like this. We note that the velocity triangle at the inlet is like this, where theta is the vane angle at the inlet. In this case it is given as 20 degree. Vr1 is the relative velocity at inlet. V1 and Vf1 are equal, and at the outlet triangle the radial velocity, relative velocity will be radial. Then this V2 will be perpendicular to the motion of this vane. The angle made by this V2 with the direction of the when is beta, and the angle made by the relative velocity with the direction of the when is phi. So value of phi is given into this example as 30 degree, and this u2 is the velocity or tangential velocity at the outlet, and vwt is the wall velocity at the outlet. So next we will move on. What is asked in the problem to find out? It is the work done by the impeller per unit weight of the water. So what is work done? The formula for the work done in the centrifugal pump. If we reverse engineer this, we will get this. The formula for the work done per second is given by 1 upon G Vw2 U2 in case of centrifugal pump. So in this case the G is constant, U2 is the tangential velocity at the outlet, which is also known, we have found out above. So the only thing we don't know is the Vw2. So Vw2 is the wall velocity at the outlet. So how to find this? To find the wall velocity in this triangle, we know that the value of theta, value of phi. What is this value of phi? From this triangle, by trigonometric relation we can find out this. Tan phi is equal to its opposite side, it is Vf2 divided by its adjacent side, which is the this much distance, which is equal to, what does this is equal to? This is the u2 minus, this is u2 minus Vw2. So this will be the equation to find out the Vw2. In this case we know this tan phi, value of tan phi, as we know the value of phi, we know the value of u2, we need to find out this value of Vw2. Again we don't know what is Vf2. So firstly we will need to find out the value of Vf2. So how can we find the value of Vf2? We know that the velocity of flow is constant. It is already given in the problem. Velocity of the flow, the velocity of the flow is constant. What does this mean? Velocity of flow is constant. It is the Vf1 is equal to Vf2. Hence if you find out the value of Vf1, we will get the value of Vf2. Hence we will find the value of this Vf1, which is equal to V1 from inlet triangle. So how to find the value of this Vf1 from inlet triangle? This angle theta we already know. We also know this u1. So tan theta is equal to this Vf1 divided by u1. Using this equation we know what is tan theta and what is u1. We can easily find out this Vf1. So let's start. From the inlet velocity triangle, tan theta is equal to Vf1 upon u1 is equal to Vf1 divided by 12.56, which is the value of this u1. Hence the value of Vf1, after putting all these values, we will get as 4.57 meter per second. So value of Vf2 will also become as 4.57 meter per second. Now from the outlet velocity triangle, we know that tan phi is equal to Vf2 divided by u2 minus Vw2. In this case, we have found out the value of Vf2. We know the value of u1, value of u2 from here. We know the value of this tan phi. So we can easily find out the value of this VW2. So after putting all these values, we will get the value of VF2 as 17.215 meter per second. Now it is very easy to find the work done by the impeller per kg of the water per second, which is given by this formula. If we put all these values, we will get the work done as 44.1 Newton meter per Newton. Okay, thank you.